Question 34. Show that y equal to x plus x log x minus 1 is the unique solution of x y double dash minus 1 equal to 0, satisfying y of 1 equal to 0 and y dash 1 equal to 2. We are given a relation between an independent and independent variable, and first we have to check whether it is a solution to the given differential equation, and we have to see whether that is a unique solution to this initial value problem where the initial values are mentioned. So given x y double dash minus 1 equal to 0, this is our equation 1, and our relation y equal to x plus x log x minus 1 is our equation 2. Now we will find y double dash from our relation and then substitute into this differential equation to see whether this differential equation reduces to an identity. If that is the case, it is a solution. First we will see whether this is a solution to this differential equation. So d by dx on 2, we get y dash equal to 1 plus product function differential x into differential of log x, so 1 by x, plus log x into differential of x 1 minus differential of 1 is 0. So we have y dash equal to 2, 1 plus 1, 2, this cancels out, 1, 2 plus log x. So we have our equation 3. Now d by dx on 3, we get y double dash equal to 0, differential of log x is 1 by x. So we have our equation 4 y double dash. Now we will see whether this on substituting into equation 1 reduces it to an identity. Using 4 in 1, we get x y double dash minus 1, x into y double dash is 1 by x minus 1 equal to 0. So this becomes 1 minus 1 equal to 0 or 0 equal to 0. So it reduces to an identity. The differential equation reduces to an identity. So our given relation is a solution to this differential equation. And now we will see whether the initial values are satisfied, initial value conditions are satisfied. We will copy everything to a new page, this function and y dash and y double dash. So we have y and y dash. So y of 1, it is y of 1 equal to, using 2 we have y of 1 equal to 1 plus 1 into log 1, which is 0, 1 dot 0 minus 1, 1 plus 0 minus 1, which is equal to 0. And y dash, using 3, y dash 1 equal to 2 plus log 1, 0 equal to 2. So in the given question, y of 1 is given as 0 and y dash 1 equal to 2. So y of 1 equal to 0 and y dash 1 equal to 2, both initial value conditions are satisfied. So we have now a function y equal to x plus x log x minus 1 as a solution to this differential equation, satisfying these initial values. Now we can apply uniqueness theorem to see whether this solution is a unique solution to this initial value problem. So if we just see the uniqueness theorem, it says for a linear differential equation, second order linear differential equation, a0x y double dash plus a1x y dash plus a2x y equal to r of x, where these a0x, a1x and a2x and r of x are continuous function on a given interval, this a to b, and a0x for no value of x in that interval a to b should be 0. a0 of x is not equal to 0 for each x element of ab, then the uniqueness theorem states there exists a solution y of x satisfying some initial values. Y of x0 is equal to c1 and y dash x0 is equal to c2, and the solution is defined over interval a to b. So we have to see whether these, in our differential equation, whether these a0, x, a1, x, a2, x are continuous function, r of x are continuous functions, and we have to see whether a0x is becomes 0 in any value we define in that interval, which and given the initial value conditions are satisfied, we will using uniqueness theorem we can say this y of x is the unique solution that we got. So I will do one thing. Sorry. This is our differential equation, and this is the general form given in the uniqueness theorem. So comparing, we can say a0x equal to coefficient of y double dash, which is x, and a1x is equal to coefficient of y dash, which is 0, and a2x equal to coefficient of y, which is 0, and r of x is equal to 1. So all these functions, now we have to define an interval where our solution y equal to x plus x log x minus 1 is defined. So we have a log x here, so we can take the open interval 0 to infinity. So x0 equal to 1 is inside this interval, and in this interval we can see that a0x, a1x, a2x and r of x are all continuous functions, and this solution is defined in this interval, and it's open interval, so it is defined in this 0 is not included, so this is defined, and y of 1 is equal to c1 and y of 1 is equal to c2. This c1 and c2 we as in the question it is given as y of 1 is equal to 0 and y dash 1 0 and y of y dash 1 equal to 2. So these initial values are so these given satisfying these initial values and this solution in a in interval 0 to infinity, these functions are continuous. So using this we can say that this solution is a unique solution to our equation using the uniqueness theorem. So we got for question, this is the solution to question 34. Y equal to x plus x log x minus 1 is a unique solution to this differential equation.